Hey, and welcome back to my channel. I really appreciate you being here. The last video that I did, I literally went over the first 25 questions. So if you have not had time, make sure you hit that link right above this video. That way you can go to the first video. This will be two of four actually, since it's the second video in a 4-part series. So we've been working on 25 questions at a time. So today we're going to start at 26. But if you have not had time, make sure you like and subscribe and hit the notification. So when the videos come out, you will be able to know first thing first when it does, and you'll have access earlier than other people. So we're going to start back. We're going to talk about the alpha, like type 1, type 2 errors that we talked about before. So if a researcher changes the significant level from 0.05 to 0.001, then A, alpha and beta errors will increase. B, alpha errors increase, but beta errors decrease. C, alpha errors decrease, however, beta errors increase. And D, this will have no impact on type 1 and type 2 errors. And remember that we talked about type 1 is a false positive and type 2 is a false negative. So when you look at 0.05, right? 0.05 meaning that there is a higher chance of significance. And now we're reducing that to 0.001. And remember, if you need to pause the video to try and get your answer, I would say pause it after each question and then unpause it to get the answer. So alpha errors will decrease. However, beta errors will increase. So what this just means is that there will be a decrease in false positives, right? Because you apparently have a bigger population with this sample. If you are saying it's now at 0.001, right? You would think of the one in itself that because of the bigger population, you will have less room for error, right? But also it just takes away from the fact that there is no significant difference, right? You move from a 0.05 to that's considered a highly significant to a lower one. So that's why it would decrease the false positive. However, it will increase the beta. So it's hard to tell if something has a level of significance if you have a 0.001, right? The higher the number or level of significance, then it will show like a strong relationship between two variables. A counselor believes that clients who receive assertiveness training will ask more questions in counseling classes. An experimental group receives assertiveness training while a control group does not. In order to test for significant differences between the groups, the counselor should utilize A, the student's t-test, B, correlation coefficient, C, a survey, or D, an analysis of variance or what's called an ANOVA. Right? So be a student's t-test, right? So because in this example right here, we have one group receives assertiveness training, right? So we have one group while a control group does not, right? We have two groups. So always think of the t-test as two groups, right? It'll help you remember that with the student's t-test. And sometimes it's shown as a student's t-test or just a t-test in itself. All right. The researcher in question 27 now attempts a more complex experiment. One group receives no assertiveness training. A second group receives 4 assertiveness training sessions, and a third receives 6 sessions. The statistic of choice would be. Now make sure you pause. An ANOVA. So ANOVA stands for analysis of variance. You will use an ANOVA when you have 3 or more groups, right? 3 or more independent variables. And because you have one here, right? Then you have another one here, right? Trying to use this touch screen, but you have one group receives no assertiveness training. The second group receives 4 assertiveness trainings. And then you have a third group that receives 6, right? So because you have three different independent variables, right? Then you would use the ANOVA. You would use, it's also called a factorial ANOVA as well. If the reader in the previous question utilized 2 independent variables, the statistic of choice will be a two-way ANOVA or a MANOVA. So the reason why it would not be the t-test is because if you go back to the previous questions, right, they're still using 2 independent variables, right? Same thing for here, 2 independent variables, and then you also have the control group. So all in all together, that'll be 3 groups, right? All right. I hope that makes sense for you. If not, just rewind it. All right. So to complete a t-test, you would need, or you will consult a table value of t. In order to see if significant differences exist in an ANOVA, you would A, consult the mode, B, consult a table for t values, C, consult a table for f values, and D, compute the chi-square. All right. If you chose C, you are correct, right? The F values, right, are used to determine whether to accept the null hypotheses, right? We're looking at an error of variance if our results are due to chance or probability of error. And we also are looking at the variance of the data. Variance, remember, is how far or close the schools are from the average, okay? All right. Which level of significance will best rule out chance factors? Would it be A, 0.05, B, 0.01, C, 0.2, D, 0.001? So I always look at this as if you move the decimal over and it's a backwards 100, because this just means that there is a 99% chance, right? Even a smaller number, that there is a significant level. Even if you don't look at it like that, think of how 0.001 is the smallest number here, right? So if it's the smallest number here, that means that it will rule out any probability of error. And that's what chance factors mean, right? When a researcher uses correlation, remember we said correlation is comparison, and there is no direct manipulation of the IV. A researcher might ask, for example, how IQ correlates with an incident of panic disorder. Again, nothing is manipulated, just measured. In cases such as this, a correlation coefficient will reveal A, the relationship between IQ and panic disorder, B, the probability that a significant difference exists, and C, an F test, and D, percentile rank. I am hoping that you picked A. Since we're not doing any manipulation, we're not doing anything but looking at information, then we're going to choose A because we're looking at the relationship between IQ and panic disorder. This is some things you would do if you're looking at existing research that's already been published, it's out there, and you're just pulling up information and looking at their actual research and their results. If data indicate that students who study a lot get very high scores on state counselor license exams. Then the correlation between study time and LPC exam scores would be positive, right? Because there is a correlation, right? So we're looking at a study and the data from that study after I manipulated, or the researcher manipulated, and the data results indicated that the high scores were in correlation between study time and LPC exam scores, then of course it would be positive, right? Which of the following would most likely yield a perfect correlation of 1.00? Again, you move that decimal over to the right and it's 100, right? So A, IQ and salary. B, ICD diagnosis and salary. C, length in inches and length in centimeters. And D, height and weight. Hoping that you pick C, right? Because the same thing in inches, the same thing in centimeters. It's just done differently, right? It's a perfect correlation. A good guess would be that if you would correlate the length of K-CREP graduates' baby toes with their NCE scores, the results would A, be close to 0.00, B, be close to a perfect 1.00, C, be close to a perfect negative correlation of negative 1.00, D, be about a plus 0.70. Now, interesting. Let's look at the answer. I'm hoping you chose A, because how do we even measure that? And how does that correlate? And that goes back to correlate causation, right? Just correlation does not equal causation, right? You can say something correlates with something, but it doesn't mean that it causes what you're saying. And that's why it's important to make sure that you read your research, you understand it, and look at the significant level. But this will definitely be a 0.00. Dr. X discovered that the correlation between therapists who hold NCC status and therapists who practice systematic desensitization is 0.90. A student who pursued Dr. X research told his fellow students that Dr. X had discovered that attaining NCC status causes therapists to become behaviorally oriented. The student is incorrect because A, systematic desensitization is clearly not a behavioral strategy. B, this can only be determined via a histogram. C, the study suffers from longitudinal and mature rational effects. And D, correlation does not imply causal. And we just talked about this, right? I'm hoping that you picked what I think you picked. Hoping that you picked D. Correlation does not imply causal, right? This is a good representation of a type 1, well, yeah, type 1, which is a false positive, like a error, right? Which is the alpha. We talked about one, like type 1 and type 2 errors. This would be a good definition or a good review of a type 1 error, because this is a false positive. Someone's presenting research that doesn't even measure what this person is measuring. It doesn't have any face value, right? Or face validity. And that's going to come up later when we talk about face validity. Behaviorists often utilize N equals 1. And N just means the number of people in your study or you're looking at, right? So it could be 1, 2, 3, 4, just depending on how many people you're working with, which is called intensive experimental design. The first step in this approach would be to A, consult a random number table. B, decide on a non-parametric statistical test. C, take a baseline measure. D, compute the range. So it's going to be C, right? I'm a behaviorist, right? So my goal is to modify behavior. So typically, I will have to get a baseline of what the client is currently presenting with. That way I can have my baseline of how this person typically act based on the unwanted behaviors that needed to be changed or want to be changed, right? That way I can also measure if my interventions are working to decrease those actual behaviors, those unwanted ones. In a new study, the clients do not know whether they are receiving an experimental treatment for depression or whether they are simply part of a control group. This is nevertheless known to researcher. Thus, this is a double-blind study, B, single-blind study, C, baseline for an intensive design, right? We just talked about that, right? For behaviorists, right? And its number of your population, which is 1. And then D, participant observer model. All right. So it's going to be a single blind study because only one group, right? The control group, right? They do not know whether they're receiving the depression, the treatment for depression or not, right? Just the researchers. Now, it will be a double-blind study if the researchers, as well as the experimental group and control group, all of them did not know, right? Be a double-blind study. A large study at a major university gave an experiment group of clients a new type of therapy that was intended to ameliorate test anxiety. The control group did not receive the new therapy. Neither the clients nor the researchers knew which students received the new treatment. This was a double-blinded, right? The researchers didn't know, neither did the participants do, right? This also helps to decrease biases, right, in testing. Experimental is to cause and effect, as correlation is to A, blind study, B, double blind study, C, N equal 1 design, and D, degree of relationship. Now, the best I can tell you is to think about what you already know and what we already talked about, and then you can single out the right answer. So, right, remember I said the correlation is comparison, right, between two variables. So it's going to be the degree of relationship. Does A cause B, right? Does the independent variable is causes the dependent variable, right? Is there a degree of relationship between those two, right? In a normal curve, the mean, median, and mode all fall precisely in the middle of the curve. From a graphical standpoint, the so-called normal Gaussian curve, named after the astronomer mathematician K.F. Gauss, looks like A, symmetrical bell, B, the top half of a bowling ball, and C, the top half of a hot dog, and D, a mountain which is leaning towards the left. I'm hoping you pick a symmetrical bell. So the idea is that if you take the normal bell curve, normal distribution, you fold it in half, each side is equal the same, right? That's what symmetrical means. If you fold it in half, it'll be the same on each side. There's also a video that I talk about with the bell curve that goes a little bit more detail about that. You should check that out as well. I'll put that in the description box. The most common measure of central tendency are the mean, the median, and the mode. The mode, right, is A, the most frequently occurring score and the least important measure of central tendency. B, always 10% less than the mean. And C, arithmetic average. And D, the middle score in the distribution of scores. Okay, we're looking at the mode. Yeah, so the mode is a number that occurs the most when you put your data. So, for example, if I got the scores from my class and I line up all the scores in order. And if I see more than one of the same scores, that will be my mode, right? The scores that show up the most. A bimodal distribution has two modes, right? Most frequently occurring scores. Graphically, this looks roughly like A, asymmetrical bell-shaped curve, B, a camelback with two humps, C, top half of a bowling ball, and D, a mountain which is leaning towards the left. Okay, so we know that asymmetrical is even, but if we have two modes, that means that we have two high scores, right? Um, then that would mean that we would have what? A camelback with two humps, right? So it wouldn't be a normal bell curve because a normal bell curve would have one mode. But if there's two modes, right, then we would have that camel hump. In a basic curve or so-called frequency polygon, the point of maximum centration is the A mean, B median, C mode, and D range. Mode, right? The maximum point of concentration, because if there are numbers that are frequently seen, then it's going to be up there twice, right? It's going to be the highest part of that normal distribution bell curve. And you think about frequency, right? How frequency, how do the numbers show up, right? Is there more numbers that show up that are the same? The most useful measure of central tendency is the A, mean, often abbreviated by an X with a bar over it. B, medium, often abbreviated by MD or MDN. D, point of maximum centration or concentration. D, point of maximum concentration. So the most useful measure of central tendency is the mean, right? It's one of the easiest ways to calculate your scores, right? And it's used very often with like t-tests, right? All right. In a career counseling session, an electrical engineer mentions 3 jobs he has had. The first job paid $10 per hour, the second paid 30 per hour, and the third paid a higher rate of 50 per hour. The counselor responds that the client is averaging 30 per hour. The counselor is using a Pearson product moment correlation coefficient, B, a factorial design, C, the harmonic mean, and D, the mean. I am definitely hoping that you pick the mean, right? The mean is when you take all the scores, or you take, in this case, the 10, the 30, and the 50, right? Add them together and divide them by 3. And then you would get 30 per hour. All right. So just when you're trying to look at the average, you add up all the scores and how many ever individual scores you have is what you would divide that total score by. Okay. So from a mathematical standpoint, the mean is merely the sum of the scores divided by the number of scores, right? We just said that, right? The mean is misleading when A, the distribution is skewed, B, the distribution has no extreme scores, and C, there are extreme scores, A and C. So it's going to be when it's skewed, right? And also when it have extreme scores, right? Because your average is not going to be in the middle of that bell curve. A skewed distribution looks like the curve is being pushed to the left or to the right, right? You have a negative skewed, and you have a positively skewed. And that's something that we'll talk about later on as we go further into the questions, right? Also, if you have extreme scores, right? Scores do not fall within the mean. Maybe it's 2 to 3 standard deviations out. Could be 4, right? Either on negative or positive, right? All right. When a distribution of scores is not distributed normally, statisticians, yeesh, I need some coffee, call it the Gaussian's curve, right? That's the normal bell curve, right? Normally distributed, so we know it's not A. B, a symmetrical bell-shaped curve. C, a skewed distribution. D, an invalid distribution. I am hoping that you have picked C, right? It's skewed. It's not a normal bell curve. Imagine a bell curve being pushed to the left, skewed, or to the right, skewed, right? And let me see if I can just show you what a skewed distribution looks like. And the one that I like to use the most when I'm doing tutoring is the one that has 3. I'm not quite seeing it, but I will just use this one here. I like the colors. It's kind of cool. All right, so skewed right and skewed left. So in the middle, you have a normal bell curve, right? Normal distribution. The mean, mode, and median is in the middle, right? But if it's skewed to the right, then right, that will be negative. But we're looking at this tail point, right? On the right, or the left side of your screen. We look at the skewed right. We're looking at the little tail that's coming towards the normal bell curve, right? That's how we know the tail is pointing to the right. When you look at the skew to the left, well, all the scores are pushing to the positive. You're looking at that tail right there is going to the left. I know it looks weird, but that's just how they have it here. This is how it's explained, right? So if I think the example that's going to come up is if you give first year students a test for you give them the NCE, right? What do you think will happen? Do you think it'll be skewed left or skewed right? If you chose skewed right, then you're correct, right? Because all the scores are going to push into the negative, right? Because they're going to probably fail because they just started their counseling program. They haven't learned anything, right? So then it will be looking at that tail part and it will say, oh, it's a skewed right. Hopefully that makes sense. And then we'll talk about it more. Okay. The median is A, the middle score when the data are arranged from highest to lowest. The arithmetic average. C, the most frequent value obtained. And D, never more useful than the mean. All right, so the middle score when the data are arranged from the highest to the lowest. So if you do all the scores, arrange them like it just says here, right? And then you look at the scores in the median. Typically what I do is I put all the data, all the numerical plots for each individual one, put them in order. I go from the left to the right and count all the way down to the middle. And then you get your median. Last one for tonight. In a new experiment, a counselor educator wants to ferret out the effects of more than one IB. She will use a blank design. All right. A person, product, moment, R. B, experiment, rank, order. And C, factorial. And D, Solomon, 4-group design created by psychologist Richard L. Solomon. So, because there's more than one IB, guess what we're choosing? Factorial, also known as factorial ANOVA, right? We talked about that before. Having more than one IB is, well, 3 or more, right? It's when you're going to use it. If you have 2 two variables, right? If you'll have a t-test, right? T-test would be like the control group and the independent variable. But when you use a factorial ANOVA, you're going to have more than one IB, which will cause you to have two independent variables or more and one control group. All right. So let me know in the comments if there are any questions about what we talked about today. Thank you for just being here with me. I know research can be overwhelming, and I hope that I was able to make it a little clearer for you. But feel free to let me know in the comment section. If you haven't subscribed already, let me know. But otherwise, have a great, amazing night